my name is Jung. I work for Data Solution. I work for data scientist almost 25 years, and now I study data science and data mining in university. Today, I'm going to talk to you about big data and predictive analytics. The first thing I want to tell is what we live in big data era. In other words, we already entered the zettabyte era. According to the 2012 Data Universe, the amount of data accumulated around the world is 2.8 zettabyte. 2.8 zettabytes equal to 2,837 exabytes. And 1 exabyte nearly 2.5 times as large as the US Congress Web Archive. So 2.8 zettabytes is 7,000 times larger than US Library of Congress of Web Archive data. The United States has 1/3 of the whole data, and India, China, and Western Europe has another 1/3, and the rest of the world has the rest. Let's look at the average amount of data stored per company with 10,000 or more employees. Manufacturing companies accumulate on average 1,798 terabytes of data, and government agencies also accumulate an average 1,312 terabytes of data. Let's check the data size measurement unit. Capacity of 3.5 inches floppy disk is 1.44 megabyte. 1,000 megabyte equal to 1 gigabyte. Today's USB key drive typically hold single or double digit gigabyte. 1,000 gigabyte equal to 1 terabyte. Today's large consumer hard drive hold single digit terabyte. 1,000 terabyte equal to 1 petabyte. The information in every US academic research library represent about 2 petabytes of text. 1,000 petabytes equal to 1 exabyte. So every word ever spoken by every person ever can be represented in about 5 exabytes of text. 1,000 exabytes equal to 1 zettabyte. So 1.3 zettabytes will be transmitted over the internet in 2016. By 2019, global internet traffic will exceed 2 zettabytes per year. So the data is exploding. 90% of the world data was created in the last 2 years. Total transactional data is less than a few terabytes. However, a human file was added. It exceeded several petabytes. And the social interaction data was added. It exceeds several exabytes. With the addition of machine-generated IoT data, it has reached several zettabytes. So according to the definition of big data made by McKinsey consulting company in 2011, the big data refer to the large-scale data that exceed the capability of data collection, storage management, and the analysis of existing database management tool. However, the definition of big data is substantive and will continue to change in the future. Also, the amount of data is relatively by industry sector and range from a few tens of terabyte to several petabyte in current standard. So what is big data? Big data is literally big data, and how big is called big data? From several terabyte to several petabyte. The big data is various type of data. Numeric data and the encoded character data is called structured data. But text and visual, sound, and image data is called unstructured data. XML data and tag data is called semi-structured data. And big data is also rapid changely data. So we also call it real-time data or streaming data. Social media data, email data, CCTV, sensor data, like MES or RFID is also treated as big data. GPS data, navigation data, traffic information data, and communication data, log data, machine-generated data are all big data. Is it hard to handle big data? Why? That's because it is too big, and also it is too various in type, and also it is too rapid changing. But big data have a lot of potential value in various industries. McKinsey's 2013 research report, Game Change, 5 Opportunity for U.S. Growth and Renewal, mentioned that U.S. must make a bold investment in big data to maintain its dominance as an economic powerhouse. There are 4 fields of manufacturing, retail, and healthcare, and public sector has a high investment value for big data. Because in these 4 fields, big data capturing is relatively easy, and on the other hand, the potential value of big data is relatively high. McKinsey predicts that big data will directly raise U.S. GDP by up to $325 billion per year in retail and manufacturing, and it is predicted that the big data will save cost by up to $285 billion per year in healthcare and the government sector. According to a 2018 survey by Wikibon, the Global Market Research Institute, the global big data market is expected to reach $103 billion in 2027. Total big data hardware, software, and service CAGR from 2017 to 2027 is 11%. The service CAGR is 9%, software CAGR is 16%, and the hardware CAGR is 9%. According to the Gartner's 2013 survey report, 687 companies that have adopted big data respond that the biggest difficulty in adopting big data are as follows. Number 1, determining how to get value from big data. Number 2, defining our strategy. Number 3, obtaining skill and capability needed. So this is a big data utilization stage. Use of big data can be divided into the following 4 steps. The first step is collection or collect of big data. The second step is the big data storage and management. Third step is to come up with the business insight by a big data analysis. The fourth step, it is a decision-making optimization step using the business insight. Let's look at more closer look. In the step of big data connection and collection, big data can be connected or collected in 4 different ways. Relatively small data use downloading and uploading. When the system directly linked to ESP, Enterprise Service Bus, connect the data by EDI, Electronic Data Interchange. When the system connected over the internet, connect the data by API, Application Programmable Interface, and also using a crawler, data is collected from the website, web document in a HTML format. During the step big data storage and management, structured data is stored in database, relational database, and semi-structured data is stored and managed in the relational database through XML parsing. Unstructured data is stored and managed in Hadoop file system. The third step is drive business insight by analyzing big data. At this step, we use a wide variety of analytical techniques like tabulation, visualization, statistical analysis, data mining, and the machine learning, the predictive modeling, streaming analysis, text analysis, image, video, and voice analysis. The final step is to drive the business insight to the decision optimization. The technique applied to decision optimization are as follows: scoring engine, rule engine, recommendation engine, and also optimization engine. The second thing I want to tell you is that the biggest effect of big data comes from prediction. In other words, knowing the future can do so many things. Japan's Nomura Research Institute publishes a report on an evolutionary direction of corporate data utilization. They said that the company data utilization is evolving from analyze the present situation to the predicting the future. In the 1980s, company built the formal reporting system to get answer to the what happened. In the 1990s, the company built a multi-dimensional analysis system such as OLAP to get an answer to why this happened. In the year 2000, the company built the monitoring system such as dashboard and scorecard system to get answer to what is happening now. In the 2010s, the company built the predictive analytics and optimization system to get answer to what will happen in the future. Predictive analytics and optimization is a representative area of a big data application. Online and offline interaction data between company and customer determine the success or failure of future business. Let's look at some of the pioneers driving innovation through predictive analysis. Oliver Assenfelter, who majoring in economics at Princeton University, came to the center of the controversy in the wine industry by analyzing the number of evaluations, the quality of Bordeaux wine. Instead of evaluating the quality of wine by wine experts, rotating it in the mouth and then spit it out, we analyze the relationship between the characteristic of wine and the auction price using statistics, and announce the quality formula below. The wine's quality is equal 12.1.5 plus 0.00117 times the winter precipitation plus 0.0614 times average temperature minus 0.00386 times harvest season precipitation. So, in fact, he was treated as a Greek with a great sarcasm for predicting that the 1989 would be the wine of the century rather than the 1986 Bordeaux wine. So, and his 1998 would be a great wine. It was confirmed that, and this is he is correct. The second story is about the person who built the stock market prediction model. In the early 1990s, Dr. John Elder bet all of his lifetime saving of $40,000 in retirement saving on the stock market prediction system he developed. Nowadays, we call a black box trading system. The forecasting system John developed gave his asset a 40% annual return and doubling in a 2 year. After that, John managing the fund with 20 millions in investment from several investors. A few years later, it has grown into an investment fund worth hundreds of millions of dollars. In 1995, John launched Elder Research Company, which is now the largest data science consulting company in North America. What you see on the screen is Elder Research's health insurance fraud crime detection probability prediction system, which is being served in United States now. The third story is about the people who create the crime prediction model. UCLA anthropologist Professor Brigham and the Santa Clara University mathematician Professor Muller applied the data on about 13 million crimes that occurred in the Los Angeles area over the past 80 years to earthquake and aftershock prediction algorithm. This led the development of system called the PredPol that predict the future crime rate 12 hours in advance. The PredPol system has been used in US, UK, and Uruguay since 2011. After introduction of this PredPol system, thief crime decreased by about 13% and the robbery by about 22% in Los Angeles area. Unlike existing hotspot system that simply aggregate the show crime data, this PredPol system show more than double the prediction accuracy because advanced mathematics and machine learning technique is applied. Using historical crime data and new crime data every day, PredPol predict and inform the area which a high probability of crime within 12 hours in a 150 meter by 150 meter square area. The result predicted through predpoll inform the frontline officer on the hotspot of the day and ask them to pay more attention than other area. In addition, while patrolling the hazard area, it is prevent from leaving the patrolling area through business contact. Let's take a look at the operation flow of predpoll system. The first, access the predpoll system through your internet browser. Second, set up the crime mapping and prediction setting. Third, specify the type of crime. The crime mapped simultaneously. The micro-scale mission target at 500 feet by 500 feet neighborhood boxes. You can also drive report on paper and also smartphone to tablet. And what is predictive analytics? Predictive analytics is a technology to create and utilize a predictive model to predict the future behavior of an individual person by learning from data to make a better decision. A predictive model is a mechanism that predict what will happen to an individual, such as a click, purchase, lie, death, or payment, or mortgage. The higher the score, the higher the probability that the individual will perform the predictive behavior. Successful application of predictive analytics require answering following two questions. What will you predict? The type of behavior, action, event, occurrence, etc. To be predicted. How to use? Decision making based on predictive result, action taking according to each prediction result. The predictive analysis is divided into the step of creating predictive model and the step of deploy the predictive model. In the step of creating, predictive modeling or machine learning is applied to the historical data to create predictive model. Once you create the predictive model, so in the deployment step, the predictive result is generated by applying the predictive model to the new data. Now I will introduce an example of big data and predictive analysis applied to the Korean government. The first example is a score-based workplace targeting for labor supervision. The source of this slide is the 2016 government 3.0 Big Data Knowledge Sharing Contest information packet. So what is labor inspection? The entire process of ensuring compliance with the labor standard by conducting a field survey on workplace and dormitory and other annexed building, investigating any violation or labor law and issues correcting order or taking administrative or judicial action. In 2014 alone, 1,074 inspectors conduct a regular inspection of over the 6,000 workplaces, and the special inspection was conducted over the 8,000 workplaces. The main item of inspection was whether the basic employment order was complied with, such as compliance with the minimum wage, conclusion of written contract, and the prevention of array in wage. There are three current issues. The first, determining of the labor inspection target greatly rely on the third-party reporting, experience, and the inspector's institution, as well as a past record. The second, insufficient number of inspectors compared with the number of workplace subject to inspection. Third issue is inaccuracy in workplace subject to a specific terms and labor inspection. For example, an inspector who is supposed to perform a labor inspection related to the disabled person is dispatched to a workplace where there are no disabled employees. In 2014, 3,203 out of 4,167 workplaces violate the Labor Standards Act, including violation of minimum wage, violation of written contract, delay payment wage, violation of working hour, and the violation of protection of week. Even situations where the number of inspectors is insufficient compared to the number of business sites. There is a need for vulnerability type and indicator, which are quantitative criteria based on the big data to select a target for more efficient inspection of business site. Primary purpose big data analysis is through quantitative selection process for inspection target. The following can be achieved: increase work efficiency and performance of inspector, decrease in the number of industrial safety accident and workplace. They improve the labor condition, including less labor management, dispute more worker. Coming from vulnerable group of society, birth rate being sustained or increasing. Deployment of basic policy. Secondary purpose is identifying the workplace that is similar to the have caused social controversial. The following can be achieved: the pursuit of special, planned inspection, preemptive response. So task 1 is selecting vulnerability type and the vulnerability index. Task 2 is identifying workplace that are similar to business that has caused social controversy. This is the big data analysis system architecture. The first, bring a big data accumulate in government organizations such as Ministry of Employment and Labor Health Insurance Company, Occupational Safety and Health Agency, Korea Employment Information Service, Labor Welfare Service, and the Korea Employment Agency for the Disabled through online and offline linkage. Second, the imported data is stored through the consistency check, cleaning, verification, and the DB modeling. Third, statistical analysis and data mining are applied to the stored data to generate various analysis results and store them in the storage. The two key big data analysis models are vulnerability index model and the similar workplace model. The first, stored analysis results are provided institutional user through web-based visualization. Let's take a closer look at the vulnerability index model. A logistic regression model is a statistical model used to analyze the causal relationship between two or more categorical dependent and independent variables. The vulnerability index model is a model that predicts the likelihood of a violation of a specific labor standard. Act of each workplace by applying logistic regression modeling to big data and the supervisor guide the result. For example, if the workplace C, the minimum wage violation score is 75, this means that there is a 75% chance to workplace C will violate the minimum wage. This is the result of evaluating the performance of a vulnerability index model. From 2010 to 2014, 45,097 workplaces perform labor supervision. 70% were randomly extracted and applied to the create the model. The remaining 30% or 19,331 workplace and the first verification data and the workplace supervised in 2015 as a second verification data. The improvement rate in the detection of a minimum wage violation was 30% for learning data and the first verification data, and 17.8% for the second verification data. Detection of a violation of a written contract was 18.2% for learning data and 18.7% for first validation data and 12.9% for second validation data. Detection of non-payment of wage was 47.8% for learning data, 40% for the first validation data, and 56.3% for the second violation data, and etc. Now I will explain the short-term use of the vulnerability index model. Assume that there are 1.8 million total workplace and also 3,000 supervisors, and each supervisor can supervise 10 workplaces. This means the total number of supervisable workplace per year would be 30,000. So in order to check the performance of a vulnerability index model, 3,000 workplaces corresponding to the top 10% of a vulnerability index are selected through the vulnerability index model. And 27,000 workplace is corresponding to the remaining 90% are selected by applying the existing selection method. In order to check the performance of a vulnerability index model, 3,000 workplaces corresponding to the top 10% of a vulnerability index are selected through the vulnerability index model, and the 27 workplace corresponding to the remaining 90% selected by applying existing selection method. Now let's closer look at similar workplace selection model. For example, the passion pay, which report when a company doesn't give a young job seeker a proper wage because they are allowing the young people to do work they want to do. This practice is most commonly encountered in the internship at large corporations and the broadcasting and entertainment industry. Assume that such a passion pay occurred at the specific workplace. In order to prevent the spread of this social issue, the supervisory authority should promptly select a workplace that can additionally occur and supervise them so that the same issue do not occur. Create a map of similarity between working place based on the big data. A specific workplace where the social issue has occurred is placed on the similar map and select the K workplace with high similarity. Supervise to ensure that the same issue do not occur at selected workplace. This is the system screen for visualizing analytic result. The vulnerability index for each type of violation of labor standard at each workplace was printed. In addition, by displaying the vulnerability index on the map, it is possible to compare them by a local government office. The short-term use of plan is to use the vulnerability index that occurred after the end of the project to select 10% of total target labor workplace. The medium-term use plan is to expand the use of the indicator by 30% to 50% when the select a target workplace. The long-term use plan is to use the vulnerability index when select all target labor inspection workplace. The short-term performance indicator is to raise detection rate of a violation of labor supervision to 65% in 2016. The long-term performance indicator is to raise the detection rate of a violation of labor supervision to 80% by 2018. The short-term performance goal is to make labor inspection more efficient, and the long-term performance goal is to improve the working environment. Provided that the use of vulnerability index is gradually expanded up to 50% by 2018 and the detection rate is increased by 80%, the annual economic effort worth the Korean won the 50 billion won based on the resolution of late payment of wage claim can be expected over the next 3 years. Economic effect result from the resolution of late payment of wage claim through the gradually increased use of the vulnerability index. Average detection rate of 64 during period 2011 and 2014. The Korean 693 billion won of the overdue wage was paid through the guide resolution in 2015. Provided that the use of the vulnerability index is gradually expanded up to 50% by 2018, and the detection rate increased by 80%, an annual economic effect was Korean 50 billion won based on the resolution of late payment of wage claim can be expected over the next 3 years. The second case is a chronic disease intensive management system of Ministry of Health and Welfare. This system is embedded in the Public Health Information System. Let's look at the potential healthcare cost saving with the use of big data. In year 2013, the McKinsey, the global consulting company, estimated that the use of big data can generate up to $190 billion annually in US healthcare cost saving by 2020. Looking more closely, in the clinical operation stage, big data and analytics in areas such as efficiency comparison, clinical decision support, remote patient monitoring, and the transparent performance measurement can drive saving of between $75 billion and $150 billion annually. In the R&D stage, leveraging big data and analytics in areas such as R&D optimization, personalization medicine, and the pharmacy covalence can save between $2 billion and $3 billion annually. In public health stage, leveraging big data and analytics in areas such as surveillance and response can be between $5 billion and $10 billion annually. According to the WHO, the total number of people in the world who die from the chronic disease was 35 millions, accounting for 61% of total 58 million deaths 2005. The who died from communicable disease was 17.4 million, which is only 30% of total deaths. The who died from injury was only 5.3 million, which is 9% of total deaths. In Korea, year 2017, the total number of Korean population who died from chronic disease was 227,760, according for about 80% of total deaths. Who died from the communicable disease was 10%, the total deaths. Who died from injury, it was 9.5% of total deaths. So there are three categories of chronic disease management: identification, registration, and management. The first, identification, is early detection of risk group prone to chronic illness such as hypertension among patients that have not been covered by the existing management. Second, registration is enrollment in the relevant management for the group identifying early for chronic disease such as hypertension. Third, the management is intensive disease management for the registered target patient. Expected result for health institute is followed. Improved in the prevention and treatment of chronic disease, and the improvement in the use of health institute and the satisfaction level. Of course, the final goal is national health promotion. In the chronic disease intensive management model, patients are divided into three groups. The first, high-risk group, is a group of patients suffering from the chronic disease like hypertension and diabetes with the likelihood of complications of cardiovascular disease, etc. And second, at-risk group is a group of patients suffering from the chronic disease like hypertension or diabetes with the blood pressure level outside of the normal range. Third, normal group is a group of patients suffering from chronic disease but with the blood pressure level steadily remain within the normal range. Improving the control rate for each chronic disease through the continuously identifying patient and applying intensive management effort, thereby contributing the national health promotion and cost saving in the chronic disease management project. The development of a chronic disease intensive management model proceeds in 3 stages. The first step is to develop the dosing, compliance, and control rate management model to continuously identifying high-risk group for the chronic disease, targeting patients with the chronic disease prescription and clinical record for at least 3 months. The second step is develop the blood pressure change rate prediction model for intensive management of a high-risk group for the chronic disease, targeting patients with the chronic disease prescriptions and clinical record for at least 6 months. The third step is develop the chronic disease complication prediction model for early detection and the prevent of complication. It requires at least 6 months of chronic disease, prescription and the clinical related information, as well as information related to the health checkup and at least twice. For continuous, systematic and efficient intensive management of chronic disease, hypertension among the chronic disease was selected and developed by dividing it into the medication adherence management model and the blood pressure control rate management model. We also identify characteristics of each patient type and develop the predictive model for proactive management. These efforts are aimed at predicting dosing, compliance, and the blood pressure control rate necessary to achieve sustained and systematic and efficient intensive management of chronic disease. The scope of development in phase 1 is as follows. Target disease is hypertension, and we developed 3 predictive models. Predictive model for medication adherence, predictive model for blood pressure control rate, and abnormal group identification model. Medication adherence is the degree to which the patient medication taking behavior corresponds with the prescription instruction of the doctor. Generally, for patients suffering from the chronic disease such as hypertension or diabetes, it is found that closely following the prescription instruction of the doctor helps control the blood pressure and the blood sugar level better than for those who don't follow the instruction. For the purpose of this model, the rate of a prescription refill is used as an indirect means of measuring medication adherence. CMA, cumulative medication adherence, is used as a measure of a prescription refill. CMA is calculated as following. First step, calculate the period from the day of getting the first prescription to the day of getting the last prescription of the medication for hypertension during the observation period. Second step, add all the days' supply as determined in first except the day supply with the last prescription, excluded because this is the day are not included in the period of first. Third step, calculate the medication adherence CMA using the formula first component divided the second component times 100. Now let's take talks about the medication adherence predictive model. This proposed model is pre-managing the medication's adherence by calculating the medication compliance value using the predictive model. The predictive model is very useful under the following two hypotheses. Hypothesis 1 is that the higher medication adherence, the higher control rate. Hypothesis 2 is that predisposing factor, enabling factor, and the modifying factor among all the information related to the target patient affect the medication adherence. Also, we have an assumption that after getting a prescription from the doctor, the patients will have the doctor's prescription filled by pharmacy and will take medication as per the doctor's instruction. Under the above hypothesis and assumption, medication adherence is defined as follows. Total days of supply divided total number of days of visiting using the calculation method of CMA. The modeling condition is at least 2 visits to the hospital with the history of a prescription are required. The target variable of a predictive model is medication adherence. The input variable of a predictive model include the demographic variable of patient, the personal variables such as habit, clinical variable, and other derived variable like average visiting cycle, average days supply, ratio of drug dispensing at hospital, pharmacy, etc. We use modeling algorithms such as the decision tree technique, CUT, CHAID, C5, linear regression, and artificial neural network. Factor affecting medication adherence including predisposition factor, modifying factor, and enabling factor. Predisposition factor including demographic information such as gender and age, and the clinical information such as related disease. Modifying factor include treatment-related information such as supply of days per visit. Enabling factor include personal information such as income level and environment information such as place of residence are included. The data required have been extracted from the Public Health Information System data warehouse. How we can use medication adherence predictive model. Once each patient's medication adherence is predicted, all patients are segmented based on adherence and demographic information such as place of residence. Assume that the total of 9 segments are derived from A to I. Next, profile analysis is performed for each segment. The patients in segment A live in large city and average medication is 0.942, which is the highest value. Segment A is a target group for hypertension and related chronic disease management project. On the other hand, the patient in segment G live in small township and the average medication is 0.799, which is slightly high. Segment G is a target group comprising female aged 62 years or younger for the hypertension and related chronic disease management project. Analysis of characteristics of each target group segment to develop the campaign strategy best suited for each segment. Depending on the segment characteristic, various methods can be used, such as guidance through SMS, increasing number of dosing days, providing weekend treatment, connecting visit treatment, and providing night treatment on weekday. Selecting the target of the medication adherence management campaign program involved the division of target using the difference in terms of predictive medication adherence and the average days supply and taking into account the constraining factor, age, disease stage, etc. Identifying the optimal target by combining the result of segmentation and prediction based on the client database. Extract target patients that differ greatly in terms of average days supply compared with the people in the same age group based on the bottom 10% or below the average value of the medication adherence value among the same age group, and the recommendation target patients to modify the day's supply while taking into account some relevant characteristics. Select as a campaign target those who are in the bottom 10% of the medication adherence value in each disease stage. Controlling hypertension is defined as a blood pressure below systolic 140, diastolic 9 mm Hg, with the use of the antiparatensity medication. For the purpose of this model, blood pressure control rate is defined as the probability of blood pressure of a hypertension patient fell into the normal blood pressure range. Systolic BP below 140 mm Hg and diastolic BP below 9 mm Hg. Due to the use of antiparatensy medication prescribed by a doctor and the other contributing factor. Now let's talk about blood pressure control rate predictive model. The purpose of this model is to manage the blood pressure control rate in advance by driving a blood pressure control rate value using the predictive model. Hypothesis 1 is that the higher medication adherence, the higher control rate. Definition 1 is criteria for controlling blood pressure equal whether or not the control blood pressure is determined by the official index that is standard for the judging hypertension. The modeling condition is at least 2 visits to hospital with the historical prescriptions are required. The target variable of a predictive model is blood pressure control. The input variable of predictive model include medication adherence, demographic value of a patient, the personal variable such as habit, clinical variable, etc. We use modeling algorithms such as decision tree technique, Cat-Chase C5, linear regression, and artificial neural network. The factor affecting medication adherence including predisposition factor, modifying factor, and enabling factor. Predispositioning factor including demographic information such as gender, age, and clinical information such as related disease. Modifying factor including treatment-related information such as days supply per visit. Enabling factor including personal information such as income level and environmental information such as place of residence are included. Predisposition factor and medication adherence affect blood pressure control. Blood pressure control direct and indirectly through lifestyle modification affect blood pressure level control, mortality reduction, medical cost reduction, project cost reduction, etc. The data required have been extracted from the Public Health Information System data warehouse. How we can use the blood pressure control rate predictive model. Once each patient's blood pressure control rate is predicted, all patients are segmented based on the BP control rate and the demographic information such as a place of residence. Assume that we total 12 segments are derived from A to N. Next, profile analysis is performed for each segment. The patient in segment A belongs to the pre-hypertension category and average BP control rate is 81.32, which is the highest value. Segment A is a compromising patient with pre-hypertension for the related chronic disease management project. On the other hand, the patient in segment K belong to the stage 1 hypertension target group and the average BP control rate is 67.97, which is slightly high. Segment K is target group comprising male aged older than 69 years for hypertension and the related chronic disease management project. Analysis of characteristics of each target group segment to develop the campaign strategy best suited for each segment. Depending on the segment characteristic, various methods can be used, such as guide through SMS, hypertension awareness campaign, provide the medical service at night, notification service, and hospital vehicle service. Selecting the target of blood pressure control rate management campaign program involved the division of target using the predictive model pressure control rate and taking into account the constraining factor. Diseases that have the major influence on the blood pressure control rate. Identifying the optimal target by combining the result of segmentation and the prediction based on the client database. Extract target patients that differ greatly in terms of the average compared with the people in the same segment based on the bottom 10% of the predictive control rate among the same age group and recommend that the target patients take a few drugs provided that the probability of medication remain in the same while taking into account some more relevant characteristics. Select as the campaign target those who are in the bottom 10% of the predictive model pressure control rate value in each disease stage. These are the screen of predictive model into the public health information system. Left screen for the displaying the current state of a health institute's user. The center screen shows the medication adherence and the high-risk group ratio. Right screen shows the medication adherence and control rate prediction. Now let's talk about abnormal group selection model. Hypertensive patients can be divided into 4 groups according to medication adherence and blood pressure control. Normal group is a group with both high level of medication adherence and high level of control rate. At risk group is a group which is low level of control rate and high risk group. With the high risk group is a group with a low level medication adherence and low level control rate at the same time. Abnormal group is a group where BP control doesn't work but show a high level of medication adherence. The purpose of this model is to define an abnormal group by identifying abnormal pattern in the relationship between medication adherence and the blood pressure control rate, and to perform a follow-up management for this group. The target variable is determining whether it is an abnormal group or not. The input variable include such as medication adherence, control rate, demographic variable, and personal variables such as habit. The modeling algorithm for building predictive model is a decision tree, trade model. This diagram is a concept map of utilization of integrated system for chronic disease intensive management. In this lecture, we talks about the big data concept and several example, and the predictive analytic concept and several example, and also the example for the Korean government. This is a very useful tool to decision making. So if you learn more, you can apply your issues with the big data and predictive analytics. This is conclusion my lecture on big data and predictive analytics. Thank you for your attention.